This is the pre-lab for the regression lab, and this is the tidy version. I'm just going to whip through the setup. So we're going to put in our packages that we need, as always, and run those chunks. Then we'll load the data in, and this is my same data that I'm always using. And then we're just going to do a little bit of review to start. So we talked about regression before, using as a descriptive technique then, and now we're going to talk about inference for regression using a distributional approximation. We're going to use the t-distribution. So we're not going to talk about using randomization or the bootstrap here. We're just going to be talking about the distributional approximation. So I want to consider the same relationship we did in the Lab 3. We're going to look at the relationship between the highest year of school someone completed and the highest year of school their spouse completed. So we want to try and predict the highest year of school someone completed based on the highest year of school their spouse completed. So that's our explanatory variable. So the first thing we should do is a visualization of this relationship, and I would encourage you to pause the video and see if you can figure out how to do the visualization before you go on. All right, I'm going to do it. So as always, we start off with a ggplot, and then we need to tell it the name of our data set, which is GSS in this case. And then outside those parentheses, I need a plus, and then I'm going to do a geom point so that I can make a scatter plot. Inside that geom point, I need an AES for aesthetic, and then parentheses, and then I need to pick out what my x and y variables are. So my x variable, that's going to be my explanatory variable, which is highest year school completed spouse. And then my y variable is highest year of school completed. And if I control enter here, now I can see the relationship between the highest year of school someone's spouse completed and the highest year of school a person completed. And I've got this nice, looks like a moderate positive linear relationship. And then the next thing that we want to do is compute a linear model to find the regression line. So I would encourage you to try and find the model the same way we did in Lab 3 before you go on. All right. So the next thing that we need to do if we're going to do inference for regression is we need to compute a model. So let's start using the lm command. And the first thing that we put in is our response variable, which is highest year of school completed. And then we're going to use a tilde. And then we put our explanatory variable, which is highest year school completed spouse, comma, data equals, and then the name of our data set, which is GSS. So this line of code is seeming kind of long, but hopefully you can still read it. I'm going to make a linear model, and I've got my y, and then I've got my tilde and my x. And if I just control enter here, I'll get some output in my console. Maybe I can scoot this over so that we can see it more easily, and control enter again. So there's my output. But for this lab, when we're doing inference, we're actually going to need a little bit more information. So we should give this model object a name so that we can use it later. I'm pretty uncreative with my model names. I usually just call them something like M1. And then I use that assignment operator from R, which is the less than sign and the dash. And I'll just put that there. And maybe I'll put a line break in here so it's a little bit easier to see. So now I'm saying M1 gets the linear model, all this stuff, and if I control enter, nothing happens in my console. But if I scroll over here, now I have something in my environment. It's not very easy to look at this object here. So you either want to look at the output in your console, or maybe you want to run summary of M1 and then control enter there. So again, I think I need to make my window a little bit bigger so I can really look at this, and then I'll run that code again. So I've got my call, which is just kind of reminding me what my code was. I've got some information about my residuals. You can just ignore that. Most of the important stuff is in this section called coefficients, and the most important column is this column that says estimate. So that's my estimate for my intercept and my estimate for my slope. And if I wanted to, I could use LaTeX to write out the equation of that line. So here is my syntax /hat y, because it's the prediction. And then I've got my intercept plus my slope times my explanatory variable. So that is the equation of the line. If I was asked to find the regression line, this is what I'm looking for. And then we should just review how you interpret that slope value, the 0.59. I usually say for a 1 unit increase in the explanatory variable, highest year of school completed by a spouse, we would expect to see a 0.59 unit, and then it'll either be an increase or a decrease. It's an increase in this case because our coefficient is positive. Increase in the response variable, which is the highest year of school the person completed. So, and I should put in the units. I think the units are years. So for a 1 year increase in the highest year of school completed by a spouse, we would expect to see a 0.59 year increase in the highest year of school that person completed. So that would be my interpretation for the slope coefficient.